Welcome back to this Computer Science 1 video series. In this module, we'll cover recursion. This module is split into 3 parts. In this first part, we'll give an introduction to recursion and demonstrate an example. In the second part, we'll outline how to design and implement recursive functions in C. In the final part, we'll cover some pitfalls of recursion and how to mitigate them. To motivate this discussion on recursion, let's take the following challenge. Let's write a program that counts from 10 down to 1 and then prints blast off without using a loop control structure. This may seem like a toy challenge at first, but some programming languages have you doing this as part of the normal control flow, often discouraging or even forbidding traditional loop structures that we've already covered. So if we can't use a loop, then what can we use? We can use basic variables, basic I/O, conditionals, and most importantly, functions. Let me start by writing a function that prints the number n. Here's our countdown function. Given the number n, let's go ahead and print it out. But first, let's take care of the case when n is 0. Now, if the number's not 0, let's go ahead and print it out. Now, how do we set ourselves up for the next countdown? That is, if we're given 10, we'll print out 10, but how do we proceed to 9? That is, how do we print out 9? Well, we have a function that does that. This function. So let's go ahead and call it. But when we call it, we subtract 1 from n and pass that to another call to this function. This is recursion. A function can call itself on different parameter values. Let's see how it works. Let's go ahead and run this now. Our first call to countdown passes in 10 and prints it out. Then we make another call to the countdown function, but it receives a value of 9. As you can see, a new stack frame is created for each call to the recursive function. Each frame has its own local variable n. Now on the last call, n is 0, so it prints it out without making another call to the countdown function. Each stack frame is now popped off the stack. We've essentially abused the program's call stack to do our looping for us. The key idea here is that the function countdown is calling itself. This shouldn't be at all odd because we've seen plenty of instances in which a function will invoke or call another function, and that function calls yet another function, and so on. Recursion is simply a special case of this, when a function calls itself. More formally, recursion is when something, an object or a function, is defined in terms of itself. You may have seen this before in mathematics, in which you can define sequences using recurrence relations. One of the more overused and cliché of these is the Fibonacci sequence. The nth value is defined as the sum of the 2 previous values in the sequence. For example, 55 is the sum of 21 and 34 in the sequence. The sequence is defined in terms of itself. You may have also seen fractals. Here we have the Sierpinski triangle, which is created by taking a triangle and iteratively removing the middle triangle. This process continues infinitely, removing the middle triangle from each subtriangle. If you were to continue this recursive process and zoom in on any part of the fractal, it would look the same. Here's another example, the Mandelbrot set, which is often used to create pretty psychedelic fractal art like this. In the context of code, a recursive function is simply a function that makes one or more recursive calls to itself. Generally, each recursive call will pass in different values for the parameters. Recursion is often used in a divide and conquer style problem-solving strategy, as we'll see in the next part.